Moving ahead, we have a Jean and Jeffrey's tidal theory regarding the origin of our space, or let's say our Earth. So this theory is also similar to the C and M planetesimal theory, or Chamberlain and Moulton wandering star or planetesimal theory. So in this theory, there is some slight adjustment in that respective previous theory. So sun is there, and this sun have some sort of close encounter. Obviously, the close encounter by the wandering star. There were formation of tidal bulges similar to the planetesimal or the previous theory. And yes, there was an ejection of matter. Let's say there was the ejection of gas. Let's say there was the ejection of gas in terms of filaments, cigar shape, same as that of Chamberlain and Moulton planetesimal. So here we have a similar. What is the difference? Now the difference is that the C and M theory actually justifies that there was a planetesimal, small rocky, or let's say the gaseous lumps were there, they combined together, they led to the formation of planetesimal, and planetesimal further evolved in terms of protoplanets and ultimately planets. Now here in this theory, it has been mentioned that there were large blob or large gas fragments were there, means the small fragments were not there. There was directly the large gas filaments, there was a large gas fragments which were actually being released, or let's say ejected from the sun surface due to the wandering stars gravitational pull, and that directly condensed. Okay, there was no accretion, unlike in the C and M planetesimal theory. Like when the planetesimals were there, they further have a accretion, and due to the accretion they transform in terms of protoplanets and ultimately planets. But here this small to big scenario is not there. As per this Jean and Jeffrey's theory, tidal theory, there has been mentioning that the large bulb or large gas fragments were there and they directly condense. As a result of the direct condense, the contraction was there, and due to the contraction, the bigger planets were formed. So this theory is not mentioning about the planetesimals and accretion, and then they combine together, and then ultimately we have a protoplanet. So it's basically based on the direct cooling, or let's say direct condensation. So planets were mostly formed directly. Okay, planets were mostly formed directly. There was no accretion, or let's say there was almost not much accretion. So some sort of exceptions are always there, but we can say broadly the accretion is not there. So not much accretion was there in Jean and Jeffrey's tidal theory. As a result of this, what happened, that tidal dynamics were there, and these tidal dynamics actually make more reliance on direct condensation idea, unlike the planet. So if you see the difference between these two theory, there was some sort of, we can say, realignment of C and M planetesimal theory. So as per the planetesimal theory, lumps were first, gradual accretion later, and then we have what? Planets. Okay. Now as per tidal theory, this Jean and Jeffrey's tidal theory, big blobs were formed directly from sun's ejected or pulled out material that directly becomes cooled. Okay, so there is some sort of difference, a minute difference in these two setups.